When you add water to alkene in the presence of acid catalyst, so it will form alcohol. What is carbocation? Carbocation is the reaction intermediate where the carbon carrying positive charge. The mechanism of dehydration of ethanol to ethene consists of 3 steps: protonation, formation of carbocation, and deprotonation. There is no tertiary hydrogen, therefore it does not undergo dehydrogenation. Instead of dehydrogenation, it undergoes dehydration to form alkene. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to 4th session of chapter Alcohol, Phenols and Ethers. In the previous session, that is in the 3rd session, I discussed about the physical properties of alcohol as well as some of the chemical properties of alcohol. As you know, the chemical properties of alcohol is classified into 2 types: reaction due to cleavage of OH bond and reaction due to cleavage of CO bond. Last class I discussed about the reactions due to cleavage of OH bond. In this session, that is in the 4th session, I am going to discuss about reactions involving cleavage of carbon-oxygen bond in alcohols and dehydration of alcohol and how to distinguish between primary, secondary and tertiary alcohol. And I am going to discuss about 2 commercially important alcohols like methanol and ethanol, how methanol is manufactured and how ethanol is manufactured, as well as properties of and uses of methanol as well as ethanol. Therefore, this session completely deal with reactions involving cleavage of carbon-oxygen bond in alcohols. Now, the first one, reaction involving cleavage of carbon-oxygen bond in alcohol. The first one is dehydration of alcohol. Already you know that what is dehydration. Dehydration means removal of water. Alcohols undergo dehydration in the presence of protic acids like concentrated sulfuric acid or H3PO4 at 443 Kelvin. Dehydration, removal of elements of water, takes place to form alkenes. Okay? What's the product formed when alcohols undergo dehydration? When alcohols undergo dehydration, the product formed is alkene. Now I'll take case 1, case 2, case 3, that is primary alcohol, secondary alcohol as well as tertiary alcohol. Example, I'll consider primary alcohol, ethanol. Primary alcohol, ethanol. See here, I'll take the skeleton of alcohol. When alcohol is heated with concentrated sulfuric acid, so what happens? H and OH is get eliminated as well as there is a formation of water and single bond is converted into double bond. Therefore, alcohol is converted into alkene by dehydration. Dehydration means removal of water. When you add water to alkene in the presence of acid catalyst, so it will form alcohol. That is already I discussed under preparation of alcohols. Alcohols are prepared by the acid catalyzed hydration of alkenes. Acid catalyzed hydration of what? Alkenes. Here, when alcohols are heated with concentrated sulfuric acid or H3PO4, it undergo dehydration to form alkene. Now let us consider example, primary alcohol, ethanol. Ethanol, what's the formula of ethanol? CH3CH2OH. I'll remove OH and here I am going to remove H and it will form CH2 double bond CH2 plus H2O. It is ethene. And what's the temperature required? The temperature required is 443 Kelvin. Temperature required is 443 Kelvin. When the best example for primary alcohol is ethanol. When ethanol is heated with concentrated sulfuric acid at 443 Kelvin, it undergo dehydration and it will form ethene. It will form ethene. Second one, secondary and tertiary alcohols are dehydrated under milder condition. For secondary alcohol, I'll take isopropyl alcohol. Isopropyl alcohol or 2-propanol. 2-propanol was the beautiful example for secondary alcohol. Isopropyl alcohol or 2-propanol. Here I'll remove OH as well as here either I'll remove hydrogen from this carbon as well as hydrogen from this carbon. Therefore, it will form propene. It will form propene. Propene was the name of alcohol. Isopropyl isopropyl alcohol on dehydration in the presence of 85% H3PO4 at 440 Kelvin. When it is ethanol, was the temperature 443 Kelvin. When it is H3PO4, that is 85% of H3PO4, it undergo dehydration at 440 Kelvin. Next, when I consider tertiary butyl alcohol, CH3CH3CH3OH in the presence of 20% of H3PO4, at 358 Kelvin. At 358 Kelvin, there is a removal of OH as well as H, and it will become 1, 2, 3. It is 2-methyl. If I number this carbon chain as 1, 2, 3, this as a parent chain, it is 2-methyl propene. Therefore, secondary alcohol undergo dehydration at 440 Kelvin. Tertiary alcohol undergo dehydration at 358 Kelvin. This indicates that, so dehydration, reactivity of alcohol towards dehydration, tertiary alcohols are more reactive than secondary alcohols are more reactive than primary alcohols, because for primary alcohol the temperature required is 443 Kelvin, for secondary alcohol the temperature required is 440 Kelvin, for tertiary alcohol the temperature required is 358 Kelvin. From this one we can say tertiary alcohols are more reactive than secondary alcohol are more reactive than primary alcohol. Consider step 1 of this mechanism, formation of protonated alcohol. Alcohol undergo protonation, gives protonated alcohol. Already you know that what's the structure of ethyl alcohol? CH3, CH2, CH3, CH2, OH, CH3. So oxygen has 2 lone pair of electron. It takes up 1 proton from concentrated sulfuric acid. It will form protonated alcohol. OH become 1 more H get attached, and it will be oxygen takes positive ion. Therefore, this ion is called as ethyl oxonium ion. Like, what's the first step of this mechanism? Alcohol undergo protonation, give rise to protonated alcohol. This is the structure of ethyl alcohol. CH3, CH2, OH. Oxygen has 2 lone pair of electron. It takes proton from the mixture and it will form protonated alcohol. Step 2, formation of carbocation. So, protonated alcohol going to lose a molecule of water to form carbocation. This protonated alcohol going to lose a molecule of water, it will form carbocation. See here, there is an elimination of water and there is a formation of carbocation. What is carbocation? Carbocation is the reaction intermediate where the carbon carrying positive charge. So, it is carbocation and it is the slowest step of this mechanism. Therefore, it is called rate determining step of the reaction. This step is called as rate determining step. Already in the chemical kinetics, I discussed that. So, when the reaction is complex, when it takes place by 2 or more steps, the slowest step of the complex reaction is considered as rate determining step. Here, step 2 is called as rate determining step. Next, step 3, elimination of proton. Elimination of proton from carbocation. Here sigma bond is shifted here and there is a formation of pi bond and there is a formation of ethene. Therefore, the mechanism of dehydration of ethanol to ethene consists of 3 steps: protonation, formation of carbocation, deprotonation. First step is addition of proton, last step is elimination of proton, second step is formation of carbocation. This step is called as rate determining step because out of 3 steps, it is the slowest step of the chemical reaction. Now, we have already discussed that under monohydric alcohol, we have 3 types of alcohol: primary alcohol, secondary alcohol, tertiary alcohol. How do you distinguish between primary alcohol, secondary alcohol as well as tertiary alcohol? These three are distinguished by using Lucas reagent, and the test is called as what? Lucas reagent test. Already you know about Lucas reagent in the chapter haloalkanes and haloarenes. Lucas reagent is a mixture of anhydrous zinc chloride and concentrated hydrochloric acid. A solution of anhydrous zinc chloride in concentrated hydrochloric acid is called as Lucas reagent. Lucas reagent is used to distinguish between primary, secondary and tertiary. Let us consider 3 alcohols in different test tubes. Add Lucas reagent. Out of 3 test tubes, in one test tube, turbidity appears immediately because of the formation of tertiary alkyl halide. When the alcohol, if it gives immediate turbidity with Lucas reagent, that is tertiary alcohol. Tertiary alcohol. Secondary alcohol gives turbidity after several minutes. Primary alcohol's turbidity appears only after heating. Therefore, out of 3 test tubes, in any one of the test tube where there is appearance of turbidity is immediately, that is called as tertiary alcohol. After several minutes, if you observe turbidity, that is secondary alcohol. After heating only you are getting turbidity, that is known as what? Primary alcohol. Dear students, observe here identification of primary, secondary and tertiary alcohol by Lucas reagent test. By Lucas reagent test, a solution of anhydrous zinc chloride and concentrated HCl is called as Lucas reagent. Lucas reagent is a convenient reagent to differentiate between primary, secondary and tertiary alcohol. Tertiary alcohol react very rapidly to give an insoluble layer of alkyl chloride at room temperature. Secondary alcohols react in several minutes, whereas primary alcohol form alkyl chlorides only on heating. Zinc chloride probably assists in the breaking of CO bond of the alcohol. The time taken for the appearance of a turbidity difference in different types of alcohol can be used to distinguish between primary, secondary as well as what? Tertiary. Okay, observe here. Lucas reagent, it is a mixture of anhydrous zinc chloride and concentrated HCl. In case of tertiary alcohol, there is a formation of tertiary alkyl halide, immediate turbidity. In secondary alcohol, formation of secondary alkyl halide, turbidity after 5 minutes. In primary alcohol, formation of primary alkyl halide, turbidity only on heating. Turbidity only on heating. Next, dehydrogenation. Dehydrogenation means removal of hydrogen. Removal of hydrogen. When the vapors of alcohol, you know that the physical state of alcohol is liquid. In case of dehydrogenation, you have to use vapors of alcohol are passed over heated copper or silver at 573 Kelvin. Was the catalyst used for hydrogenation? The catalyst used for hydrogenation is nickel or platinum or palladium. Nickel, platinum or palladium. The catalyst used for dehydrogenation is heated copper or silver at 573 Kelvin. Primary alcohol undergo dehydration to form aldehydes. Here we have to remove hydrogen. When you remove hydrogen, it will form aldehyde plus hydrogen. Was the catalyst required here? Heated copper or silver. For example, ethyl alcohol, when I undergo dehydration, remove hydrogen, it will form acetaldehyde. It will form acetaldehyde. Next, secondary alcohol vapors, when you have to pass over heated copper or silver at 573 Kelvin, if there is a formation of hydrogen and it C single bond O becomes C double bond O, there is a formation of ketone. Therefore, primary alcohol on dehydrogenation give rise to aldehydes. Secondary alcohols on dehydrogenation give rise to ketone. Tertiary alcohols, for example, secondary alcohol, in place of R and R dash, you put CH3CH3, it is known as isopropyl alcohol. If I eliminate hydrogen, it will form acetone. It will form acetone. Next, tertiary alcohols. Tertiary alcohols undergo dehydration to form corresponding alkene. Remove OH here. Here remove hydrogen. So it will form CH3C, CH3CH2. It will form 2-methyl prop 2-ene, 2-methyl prop 2-ene, tertiary butyl alcohol. Here, no dehydrogenation, there is an elimination of water, Tertiary alcohol do not undergo dehydrogenation due to the absence of tertiary hydrogen. There is no tertiary hydrogen, therefore it does not undergo dehydrogenation. Instead of dehydrogenation, it undergo dehydration to form alkene. Alkene is formed. Next, you have so many alcohols. In that, 2 alcohols are commercially important alcohol. One is methanol as well as ethanol. Methanol is also called as wood spirit. It is manufactured from water gas. What is water gas? Water gas is a mixture of carbon monoxide and hydrogen. Water gas. What is water gas? Water gas is a mixture of carbon monoxide and hydrogen. Mixture of carbon monoxide and nitrogen is called as producer gas. What is water gas? Water gas is a mixture of carbon monoxide and hydrogen. Producer gas is a mixture of carbon monoxide and nitrogen. Water gas, mixture of carbon monoxide and hydrogen, gas known as water gas. It is pressurized at 200 to 300 atmospheric pressure, and the temperature is 573 Kelvin to 673 Kelvin in the presence of zinc oxide and chromic oxide catalyst. Was the catalyst used in the manufacture of methanol? In the manufacture of methanol, the catalyst used is mixture of zinc oxide and chromic oxide, as well as we used water gas. What is water gas? Water gas is a mixture of carbon monoxide and hydrogen. It is compressed to 200-300 atmosphere, 573 to 673 Kelvin. You will get methanol. Next, ethanol. Ethanol or ethyl alcohol is the most common of all alcohols. Manufacture of ethanol. Ethanol is made by fermentation of sugar or by hydration of ethene. Ethanol preparation from fermentation of sugar. Fermentation means whereby organic compound is larger organic molecules are broken into smaller one in the presence of enzymes. Is called as fermentation. For the manufacture of ethanol, the starting material is molasses. Molasses is a non-crystalline product of sugar which is left behind after the crystallization of sugar from sugarcane juice. The waste product which is obtained is known as molasses. From this molasses, you are going to manufacture ethanol. So this molasses contains sucrose. Which get broken down to ethanol. The fermentation of this molasses takes place in the presence of enzymes. For that purpose, you have to add yeast. Yeast secretes 2 enzymes. One is invertase. Another one is zymase. What are the 2 enzymes secreted by yeast? 2 enzymes secreted by yeast is invertase and zymase. Fermentation is a process whereby organic compound is broken into smaller molecule by enzyme. Ethanol is prepared by fermentation of molasses. Ethanol is prepared from fermentation of molasses. What is molasses? Molasses is the non-crystalline product of sugar left behind sugar industry. It mainly contains sucrose. Was the main sugar present in molasses? Sucrose, which gets broken down to ethanol. The fermentation is initiated by yeast, which secretes 2 enzymes called invertase and zymase. What are the 2 enzymes secreted by yeast? Yeast secretes 2 enzymes, invertase as well as zymase. The sugar in molasses, that is sucrose in molasses, is converted to glucose and fructose, which having same molecular formula C6H12O6 in the presence of enzyme invertase. Invertase hydrolyzes sucrose into glucose and fructose. Zymase converts glucose and fructose into ethanol and carbon dioxide. carbon dioxide. Here, bigger organic molecules are converted into smaller one in the presence of enzyme. Therefore, this reaction is called as fermentation. This reaction is called as fermentation. Observe the equation. Here, sucrose was the molecular formula of sucrose, C12H22O11. It get hydrolyzed. In the presence of enzyme invertase into glucose and fructose. Glucose and fructose is converted into ethanol and carbon dioxide. Carbon dioxide in the presence of enzyme called zymase. The carbon dioxide liberated here plays an important role maintaining the anaerobic condition. Okay. Therefore, my dear students, what are the two enzymes secreted by yeast? Invertase as well as what? Zymase. What's the role of invertase? Invertase hydrolyzes sucrose into glucose and fructose. Zymase converts glucose and fructose into ethanol and carbon dioxide. Next, properties of methanol. Methanol is a colorless liquid. The boiling point of methanol is 337 Kelvin. Methanol is poisonous and if ingested can cause blindness or even death. So, uses of methanol. Methanol is mixed with ethanol and it is sold in the market in the name of spirit. Methanol is used as a major solvent for paint and varnishes. It is also used as antifreeze for automobile radiators. It is used for denaturing ethyl alcohol. Methanol is used for making formaldehyde. These all are uses of methanol. In that, the very important use is methanol is mixed with ethanol and it is used in the name of spirit. Ethanol is used as solvent in paint industry and it is used in the preparation of power alcohol. Power alcohol means 80% petrol and 20% ethyl alcohol. 80% petrol and 20% ethyl alcohol plus traces of benzene. Power alcohol is used as motor fuel. And in alcoholic beverages like beer, wine, brandy, whiskey, they contains this ethyl alcohol as a content. Okay, these all are uses of what? Ethanol. So, my dear student, in the next class I come up with, the chapter is alcohol, phenols and ethers. I completed with alcohol. Next session I'll come up with the classification of phenols as well as nomenclature of phenols. So, from next session I'll start about phenols. So, my dear student, next session I'll come up with second organic compound, that is phenol. Until that, goodbye, take care, thank you.